Hello, we have a question. In this, uh, it is given that a motorcyclist going with engine off at a steady speed of 20 meter per second. Okay, but in test sandy stretch, coefficient of kinetic friction is 0.70. And then a question says, will the cyclist emerge from sandy stretch without having to restart the engine? If stretch is for 15 meters, okay, if so speed upon emerging. Basically, let us suppose this to be a sandy stretch, 15 meters. Initially, the speed of the cyclist was 20 meter per second. Motorcyclist was 20 meter per second. Let us say this initial speed u, and coefficient of kinetic friction is mu k is 0.70. Yeah. Now, given that if will cyclist emerge from the sandy stretch without having to restart engine? 15 meters. Okay. Okay. Now we'll be moving like if motorcyclist and a motorcycle has combined mass of m, so normal reaction will be mu m g. Now if uh, motorcycle is exerting a force of some force will be exerting some force, so maximum force it could apply according to Newton's law will be equal to the frictional force, or maximum frictional force will simply be equal to ma. So we can write ma equal to, where a is the acceleration of the bicycle, of the motorcycle, ma equal to mu mg. So a will be equal to mu g up, and definitely this will be negative because acceleration has to be negative. Okay, so from here acceleration will be equal to mu g. Now we know that v equal to u plus at, the basic formula for kinematics, v equal to u plus at, we can get the value as, I'm talking about this equation, v equal to u plus at. So v, that is final velocity, let us say v, yes, equal to u is 20 meter per second, or let us write it u, and a is minus mu g, and t for if it stops here, if it stops here, so v becomes equal to 0. So 0 will be equal to u minus gt. So t will be equal to u by mu into g. Remember, we are taking the extreme case that it has definitely stopped here. This is the extreme case. So t equal to u by mu into g. Okay. Now question says that without it lasts 15 meters. If so, what will the speed on emerging? So speed on emerging, a distance. In this case, the distance traveled. In this case, the distance traveled will be uh, could be found out using the formula s equal to ut plus half at square. So s is the distance equal to ut. U is initial velocity, no problem. Ut plus, we'll be writing minus because a is negative, minus half, a is mu g, and t is u by mu g whole square. So you'll be finding out distance from here, and compare if it is greater than 15 meters or less than 15 meters. So let us plug in all the values that are being given. U is 20 meter per second, 20 meter per second. T is U by mu g. So 20 by mu is 0.7. Let us say we will be taking acceleration due to gravity as 10, just for the sake of simplicity. 1 by 2, it will become mu g, and it is mu g square. So simply u square by mu g, it will become u square, 20 square by 0.7 into 10. So this will be 20 square by 70 minus 20 square by 140. So this is 220 square, that is 2 minus 1 by 140. So 20 square by 140. So this is 400 divided by 140, which is 2.857. 2.857. So distance traveled here is less than 15 meters. Okay. Okay. Now we observe that this distance is 2.857 is less than 15 meters. So bike will stop in between. Thank you.